Let's talk about class hierarchies today. We've used classes in Java before. You've written your own classes like checking account, savings account, game of NIM, programming assignment 7, and so on. And we've used classes that pre-exist, are predefined by Java, like scanner and string and integer and math. But so far, we've never done anything with classes where the classes related to each other in some sort of way. Each of our classes has been completely separate. So we're going to take care of the case where one class is a subclass of another. We call this topic class hierarchies. So let's recall that a class is a template of data and behaviors, or variables and methods. Variables are our data, methods are our behaviors, and an object is a specific instance of that class. So we can have a class called checking account. We can have a class called checking account and create several objects that are of type checking account. But sometimes in the real world we have things that behave similarly but not identically. For example, if you remember when we were doing our banking programming assignments, there were some things that were common to both checking account and savings account. Maybe we can take care of that a little bit more smartly in Java. So we're going to have superclasses and subclasses. In Java, every class is a subclass of some other class. So far, we haven't paid attention to this because the default of what they were subclasses of worked well enough for us. But we could create a hierarchy of superclasses and subclasses so that we can share common data and behaviors. Take a look at this diagram on the screen. We could have a class called bank account that takes care of some things that are in common for all types of bank accounts. And then a subclass of bank account would be checking account, and another subclass would be savings account. So bank account is the superclass for checking account and savings account. Checking account and savings account are subclasses of bank account. What does this mean? It means that a checking account has all the same state variables and methods as a bank account, but it can add some of its own. Same thing for savings account. So let's see how we might choose to design this. How would we take advantage of a class hierarchy like this? Well, any state variables that we use in identical ways in both checking account and savings account, we should instead implement in the bank account class so that we do it only one time and not 3 times. And any methods that are identical in both checking account and savings account should be implemented in the bank account class. So maybe in bank account, we're going to have the account number, name, and balance state variables. And for methods, we'll have things that are going to be the same for checking account and savings account. Get account num, set account num, and so on. What would we put in checking account? Well, maybe a state variable to count the number of transactions. Remember, a savings account didn't do that, but a checking account did. And some methods that are unique to checking account, like its end-of-month processing, and its deposit and withdraw and toString methods. And what would go into savings account? Well, maybe its state variable would just be interest, because checking accounts don't have that. And the methods that are unique to savings account would be add interest, deposit, withdraw, and toString. Now notice, we've got some of the methods in both checking account and savings account. That's fine. That means that the deposit method in checking account is completely separate from the deposit method in savings account. Likewise, the withdraw methods are completely different. Java's going to know when you tell a savings account to execute withdraw to look for that method in savings account. And if it doesn't find it there, it'll look to its superclass and look for one there. And if it doesn't find it there, it'll go to its superclass, and so on. Now, we can extend our hierarchy to as many levels as we need. Right now, we're showing just 2 levels. Bank account is the superclass. Checking account and savings account are subclasses of it. But suppose we wanted to create another type of account called a line of credit account, which is like a glorified checking account. It's a checking account, but you get to ask for a line of credit, effectively a loan. You get to say, hey, bank, give me $10,000. I'll pay you back at a certain interest, but let me write checks against that. So now what would we do in line of credit account? Maybe we'd add state variables of interest rate and amount borrowed, because a regular checking account doesn't need it. And we might have to change the withdraw and deposit methods so that the appropriate either line of credit part or regular balance get affected. Notice I've now got a withdraw in line of credit account and I've got a withdraw in checking account. So if I create an object of type line of credit account, it's going to, and I tell it withdraw, it's going to look first in line of credit account. If it finds a withdraw method, it'll use it. If it doesn't, it'll go up to checking account. If it finds one, it'll use it. If it doesn't, it'll go up to bank account. If it finds one, it'll use it, and so on. Now there is a class in Java that's just called object, and that's the superclass of all superclasses. If you create a class without specifying its superclass, like we've done up until now, then it defaults to having a superclass of object. And there isn't a lot of stuff in the object class, but we've already seen that it has its own version of toString that we've been overriding without even knowing that that's what we're doing. We can extend predefined classes as well as the ones that we write ourselves. So suppose a predefined class in Java does almost everything we want, but not quite everything. We could create our own class that's a subclass of the predefined class. So maybe we could create a myScanner class, because we've noticed that when we use a scanner, we often print something out to the console first and then read something in. Maybe we want to combine that into one method. So we say, I want a myScanner that's a subclass of scanner, and I'm going to create one new method called prompt. And it writes out a message, and then it reads in whatever the user types. Or maybe we create a myString class that does everything we're used to in a string, but it has a new method called compareIgnoreCase. You remember when we talked about string class in our previous lesson, we found that there was an equals ignore case. Maybe we think a compareIgnoreCase would be a nice thing to have, so we'll write one.